Yaskawa.
You're watching the PLCopen Part 4 Coordinated Motion video tutorial series. This video shows how to configure the groups of an MPiec controller for a two-dimensional gantry mechanism. Hi, I'm Matt Pelletier. Here's a quick preview. In the hardware configuration, first you add a group, assign axes to the mechanism, and define any other options. Save, and the project will be ready to program with PLCopen Part 4 function blocks. Now I invite you to follow along with me step by step through the details of this process. For this tutorial, you do need to have the class project PLCo4 training, and you should also have MotionWorks IEC Pro version 3.2 or higher. A two-dimensional gantry system is one of the easiest to understand, so it's a good starting point in the world of coordinated motion. It's basically one linear actuator mounted on another. With a mechanical system like this, you have motion in the Cartesian coordinate system, where one servo controls motion in the x direction, and the other controls motion in the y direction. PLCopen Part 4 means the controller can coordinate the motion between these two axes, and this allows the gantry system to trace out both linear and curved paths. So let's set up this system, and the first step is to go to the hardware configuration. Now the 11 steps that I'm going to go through are outlined in the quick reference guide. And we already did step 1 and 2 in the previous video. We went online and sent the project configuration and looked at the axis configuration for the units. So we're at step 3, which is to go offline and add a group. With the hardware configuration offline, you can go to the hardware tree and click on Groups and use the button Add Group. The default name can be changed to a more fitting group name. In this case, Gantry XY. Hit Enter, and that updates the group name in the tree. Now click on the group in the tree, and you choose the mechanism type. Ours is 2D gantry. At this point, the controller supports other types of mechanisms like 3D gantry, 4D gantry, 2 types of H-bots, and 2 types of T-bots. The controller can handle these different types of kinematics for these setups, but we're going to stick with 2D gantry for this example. Next, you assign the axes for the X and Y coordinate system. Just you click on the axis name, and it's pretty obvious here. We have the x-axis and the y-axis. And if you're curious about this add secondary axis, you see here that added the y-primed axis. This would mean that 2 servos are involved in moving the mechanism, and they're mechanically linked. We'll reserve that discussion for another e-learning video. For now, I'll just remove that one. And now up here at Enable Global Group Data, there's a checkbox which normally remains checked, and an IO task assignment for that variable, which can also remain at the fast task. The global group data refers to a variable that will be created with the name of your group, and the IO task assignment just defines how fast this data is updated to the controller. You can always optimize this later if you need to. There's a tab for joint limits. This allows you to set maximum and minimum positions for each axis. You don't have to use this, so I'm just going to leave it blank. Now all that's really left is to save this configuration and send it to the controller. But I do want to show you what saving does here. So we're still offline, and I will now save the configuration. You can see that global variables are being created. And 4 libraries have been added: Y-coordinated motion, Math Toolbox, PLCopen Part 4, and Group Stub. The most important library is PLCopen Part 4, and also important is this global axis group data variable that has been created. And this axis group ref variable will be important to use if you want to use the PLCopen Part 4 blocks, such as MC move linear absolute. Quick look at the help here. You see there's an axis group, and so we'll do more of that in the next video. And besides these variables and these libraries, we also have a change in the IO configuration related to this group. So with all these changes, I think you know it's time to remake the project. And 0 errors, that's good. The group is all set up on this project. Now we just need to have a controller to connect to. And I'm connected to the MP3300 IEC demo, and you need version 3.2 firmware or higher. If you would like remote access to an MP3300 IEC and Sigma 7 demo, please request by email to training@yaskawa.com. You can see how this works in the remote connection e-learning video. And first we'll need to go to the hardware configuration and send this configuration to the controller. Check your IP address. Go to the online menu, controller configuration utilities, and choose send offline configuration and execute. You do have to reboot the controller. Now the controller is rebooted, and so you can go back to the project, choose project control, and download this new project. And do a warm start. We are now ready for PLCopen Part 4 programming. And one more thing to point out is that in the configuration, there is help on this process. Under Help, Contents, and you see the section here for group configuration of mechatrolling groups. That's what we just did. So expect this help file to have the latest and greatest on all of the mechanism types that we support, and kind of walks you through the concepts that we just went through. And with that, I like to finish this off by saving the project as a ZWT that we can always come back to. Save as, choose zipped projects. I'll call it PLCo4 underscore group config. We can come back to this now at any time. Thank you for watching this video, and remember yaskawa.com/IEC as a starting point for all of our MPiec controllers and MotionWorks IEC.